Welcome. We're going to be doing Physics 220, lab number 3, the capacitor combination lab.
The equipment for this lab is pretty straightforward. Here we have a board that has 4 different capacitors of different capacitances, as well as 2 batteries. The batteries are in series, and so if we look over these 2 leads, it's the effective voltage of the battery that we're looking at. Each of these capacitors is soldered to one of these plugs, and we have these other wires that we can just plug in and then connect the capacitors in any way that we want to. We also, in order to measure across the capacitors as well as the battery, we have a voltmeter. These are the leads of the voltmeter here, and we can just measure over the capacitors to find what the voltage is over them. This one is not charged, so it has 0 volts as we'd expect. This box here is just to try to prevent charge leakage when the capacitors are charged through the voltmeter. It's just displaying in volts there. And the final piece of equipment here is a capacitance meter, which will tell us the capacitance in microfarads, microfarads of each of the capacitors. Getting started here, what we want to do is measure the capacitance of each of the 4 capacitors as well as the voltage across the battery. And so if we come and zoom in here, I've hooked the capacitance meter up to the first one, and these are labeled, but we don't necessarily know if the true values are exactly what the labeled values are. So here we can see that this is in microfarads, and so we're at 9.94 microfarads when the label said 9.5, so it's really close, but you want to use the true accurate value for your calculations, because that's what it actually is. So let's go to the next one. This one is 4.94 microfarads instead of the 5 labeled. We'll go to the next one, 3.09 microfarads. And finally, the smallest one, 1.02 microfarads. And so once we have that, we can use our voltmeter here to measure the voltage across the battery. Okay, there it is right here. So we're at 3.13 volts for the voltage over the battery. Okay, so we're going to go ahead and begin with looking at the parallel capacitors. One thing to note is that this is labeled C1, C2, C3, C4. So biggest is C1 down to smallest is C4, just so that it matches your diagram. So the first thing we're going to do is we're going to connect these leads, which lead to the positive and negative terminals of the battery. We're going to connect them to C1 here, our biggest capacitor. We're going to wait a couple seconds for the electrons to flow in and charge up the capacitor. Then we can remove the battery. Now we're going to connect C3 here in parallel. So I've connected the ends of the capacitors together, just like it shows in this diagram. C1 and C3, the ends are connected together, letting the charges redistribute between the 2 capacitors that are in parallel right now. And then we're going to just remove the wires and look at the voltage across each capacitor. So let's just start at the big one, C1, 2.38 volts. Go down to C3, 2.38 volts. So you'll notice that they are the same. So why don't you think about why they should be the same, and maybe you'll need to do the math, which is what you're going to do for the predicted. So we just give you the measured. You're going to do the math and find the predicted values based on the voltage of the battery as well as the capacitances. They should line up pretty close, and they're the same because they're in parallel. And so just a reminder that capacitors in parallel, the voltage will be the same across them. Capacitors in series, which we're going to look at next, the voltage is different across each one, but the overall charge is the same across each one. Okay. We are grounding the capacitors to make them back to 0 before we move on to looking at the series configuration. So for the series configuration, what we're going to do is we're going to connect them all in a row like this. And so in order to do that, we're going to just start with C1. I'm going to plug in the positive lead to C1 here. So positive lead's going to go here, and then I'm going to connect this end to here so that if we think about the system, it will come in here, go through here, come in, go through the next capacitor, go around, come into the next capacitor, and then here's where it'll end and go back into the battery. And so we can connect this like there. So electrons flowing through like this, charging up all the capacitors. And then as soon as that is done, we'll try to disconnect them all. And then look at the voltages just like before. So we'll start with the big one, capacitor 1. Oops, let me flip them. Okay, 0.2 volts. Capacitor 2. So the reason that it's coming up as negative is because it was snaking around, but we only care about the absolute magnitude of the voltage. So I'm just going to flip-flop the leads every time to get a positive number. 0.63 for C3, and finally for C4, 1.9. So small voltage on the big ones, bigger voltage on the small ones. Grounded all the capacitors again, and we're going to go on to the last section, which is the cross capacitor. So the first thing we're going to do is we're going to connect C2 and C4 in parallel, just like we had before. The same ends are together, and then we're just pumping positive charge in here, negative charge coming out this way. Could think of it that way. Let it all charge up so that there are equal voltage across each one. And we're going to remove it. Okay, so then what we're going to do here is we're going to just take the leads from one of the capacitors and we're going to flip it. We're crossing it, right? And so now we're going to let the charge flow between these two ends that are not connected, and then we'll remove the wires and look at the voltage. So over C2, we have 2.05 volts, and over C4, again, we don't really care about the negative, we just care about the absolute magnitude, but 2.05 volts. So they're the same at 2.05 volts, which is what we'd expect, because after we cross them, they're still in parallel, right? And so if they're still in parallel, the voltage across them will be the same. But the thing is that the amount of charge has gone down when we cross them. And so try to think about what is actually happening to the charges, right? If we thought about it, when we first charged it up, we had these connected. So we had a bunch of positive charges here, a bunch of negative charges here. If we're switching them, we're allowing the positive charges here and the negative charges here to cancel out, right? And the positives here, negatives here, they're going to kind of annihilate and become electrically neutral. Now, because the capacitors have different capacitances, there's a different amount of charge on this capacitor and this capacitor. And so not everything's going to cancel out. There's going to be some leftover charge, which will then redistribute across the two capacitors like they're in parallel. And so hopefully that helped you out with the math for that one. But that's all the data that you need for this lab, and I hope that you enjoyed it.